My name is Sean Lee, and this is a short presentation of my research project for ECE 570 class, Real-Time Post Estimation of Videos. To start this off, I want to kick off this presentation with Masked RCNN. It is a state-of-the-art method to perform object detection. It is an extended version of faster RCNN, which only outputs confidence rate and bounding boxes. So it can only do semantic segmentation. So on the left image here, you can see the person boxes are all the same color. On the other hand, Max RCNN adds a third branch on faster RCNN with object mask. So as you can see in the right picture, each person has their own color mask, therefore the computer can distinguish different objects in the same class from each other. So for the implementation of this project, I get my test images from Coco dataset and use Detectron 2 as library. First, I read the tutorial and the documentations to try implement this and follow the instructions to work with the model. However, I got many instances, for example, horses, umbrellas, trees. So I dove deeper to see if there's a way to collect only the person class, since I'm only doing human detection. And I found a way to perform the task with several lines I write myself to tackle this. What are the results? You can so for the input is the left image is the input, and the upper image on the right, that's the original output that I followed the tutorial, and at the bottom right, the image only outputs instance mask for only person class. And here are some other test images and its original input that I performed with my code. Um, so as you can see for the upper right image, there are some bounding boxes, some masks that's up there, but at the very behind, at the very back end of the image. But however, those masks got a very low confidence rate. For example, like 60-40% accuracy. So um, that's the downside for this. But however, it can still detect those people, but it's just not that accurate. But on the bottom right, you can see like all the people are detected like with a very high accuracy, and also the masks are put on like very correctly, because all of their significant features are very clear for the model to detect. So after human detection is implemented, I tried the pre-trained key point detection model in Detectron 2 to see the outputs, and here's what I got. So similarly to the human detection, people are very far from the image, like far from the camera. There are like a little amount of key points detected, so you can see some red dots at very far back. But however, like if people are very clear and they got their like the key points are like joints, so if their joints are very clear for the computer, for the model to detect, they can be mostly connected very well. Moving on to post estimation, this is the method used in the paper, Real-Time Multi-Person 2D Post Estimation using Part Affinity Fields. First, they collected the key points and create vector fields of part affinities. These two um, these two steps are done simultaneously, and the affinity fields of different parts means that um, the degree of association between different parts, or you can say different key points. Then they parse through the two sets. First the key point, second the vector fields. They parse them through with greedy inference and create the final output on the very right hand side. For the implementation of real-time post estimation, I use the data from a SID dense video dataset and work with the library called OpenPost. I performed the pre-trained model on two different videos, one video where people in it overlaps and the other doesn't. So this is the one of the output of the video I got. So as you can see, their posts are like very much perfectly estimated and very in sync with the people dancing in it. So there are some there are two possible circumstances that will happen in the video. One is that there's no overlap and the other is there will be overlap in it. So as you can see where there's an overlap in the frame here, their arms are crossed, and if the key points are not covered, the model can still estimate the pose and connect them correctly. However, if the key points are covered, the model cannot estimate the covered part. As the image on the left, you can see the very far left, the guy's wrist cannot be detected, so he's missing a part that's part of his forearm. But once the key points are revealed, the model can still estimate the whole thing again, and it's like it does it like very correctly. So on the right, that's like literally the next frame of this video, and the model can see his wrist and connect and estimate his forearm right over there. So here are some possible future plans for this implementation, or I would say project. So first, I could train the mass RCN model with some personal data and test it, like how the accuracy is, and I could create my personal human detection model, like without using the pre-trained model as I did. So for post estimation, there's currently no like evaluation algorithms with it, so I could possibly come up with an algorithm to evaluate it. Or since it works with videos, which it takes a lot of time since there are a lot of frames in just 1 second. So I could possibly find a way to speed up the post estimation on videos process. And last but not least, I could possibly write my own version of post estimation program, but this would be kind of hard for me. And thank you very much. This is a real-time post estimation on videos project.